We've done a lot of work so far, and really what we've written for a program, we could take quite a long way. We could write a lot of different programs using these methods and be quite satisfied with what we've got. However, we need to extend what we know, and we need to start involving numbers. So for example, in this one I might want to count how many people had chosen chips or how many people had chosen fish, so on, and then make some decision based on that number, or because that's what we do in a survey. We're really interested in the numbers, not necessarily what they chose. Maybe we want to use those numbers to produce a graph or some other information. So numbers are going to be important to us, and if we learn how to play with numbers with what we already know, then we will be able to write quite a lot of programs just using what we already know. So I want to start talking about numbers in this video. I also want to take a look at the shell and go back to sort of lesson 1 and why we do or don't use the shell. So first of all, let me go to the shell. I'm going to close this down because it's got items in it, and I want a blank shell to play around with, so I can just use run and the Python shell. Now I said we don't program in the shell, which is true. We don't program in the shell, but that doesn't mean you can't program in the shell. We could write pretty much all of this code just in the shell, and let me see if I can do a quick example of that. So I'm just going to type the favourite food and just do a quick check of them. So favourite food equals raw underscore input. I'm just going to do a quick one. I'm not going to put everything in that I did before. Please enter C or F or P, assuming that they know what C, F and P stand for. There we go. So there's my favourite food, and when I press enter, it automatically runs the program for me. It says please enter C, F or P. So I'm going to enter a C and my program stops. Now, writing a program like that is quite difficult. We could write the whole thing, it would work, but this is sort of what we call immediate, straight away. It answers our question straight away, and it also stores the result. So for example, I've got favourite food as a variable, which we used last time, and what I did was choose C. So if I type here print favourite food, it will have remembered the fact that we typed C for favourite food, and it will print out the answer C. Because I'm in the shell, I really didn't need to use the word print. I could have just typed favourite food. And when I press enter, it tells me that I typed C. Notice there's a little bit of a difference between the C there and the C there. So when I used print, it gave me a C without speech marks. When I said what is favourite food, it gave me the C inside speech marks. Just a little bit of difference. To us it makes no difference whatsoever. We're just using the shell to test certain items, and that's what the shell really is for. We can save our program. So if I wanted to, let's start a new shell. Let's say I wrote a program. Let's get the shell going, and I typed while true. Now I'm into writing a program. Notice it didn't print anything out. I could actually do all of this that we did before. Name equals raw underscore input. Please enter your name. Okay, and leave my program at that. So notice it hasn't printed anything out in blue. It's not asking me to enter my name, so it looks like I'm writing a program. And if I'm writing a program, then I can save my program. So if I choose File, Save As, notice we don't save in the 27. We go to Documents, My Python Files, and I'm just going to type this as shell program.py and save it. So that's saved it. I can't press F5, nothing will work as F5. If I press enter now, it's waiting for my next line of code, and if I say, well, that's the end of my code, press enter again, it's now running that program. Please enter your name, Fred. Please enter your name. It's looping round. Remember what this does, it just keeps looping forever. Please enter your name, John. Please enter your name, Enid. And I could continue. It's just going to keep asking me that same question. That is a small problem in the shell. It's never going to come back and give me my prompt. I need to learn how to stop this working. One way of doing it is by holding down the control key and pressing C or even Z, or just closing here. So if I press the close, it will say, are you sure? We've seen this message before. The program is still running. Do you want to kill it? I'm going to choose cancel, so I'm back in my program just to prove it. If I type Susan and press enter, it's waiting for the next name. If I press Control C, it just does nothing at all. If I press Control Z, it does nothing at all. If I press Control X, nothing at all. So really, I have to kill my program. So that was a shell and writing a program. If I open that file, remember we called it shell.program. So remember, I can get to previous programs I wrote and click on open. I want you to notice that number one, it looks like it's the shell. Okay, that's everything to do with the shell, but it's not. It's actually code like this, and we've got a problem. Number one, remember when I typed enter and enter, it ran the program. Now it's not. It's not doing anything at all. And if I try to press F5 and run the program and click OK, it will just tell me I've made loads and loads of errors, because now this is the shell. This is what the shell looks like, and this isn't the shell. And the first thing it sort of came across was, I have an error here. And the point is that we can't put this sort of statement into our program. This doesn't make any sense to Python whatsoever. Remember, Python looks like this. There is no Python 2.7.6 default November 10th 2013 and so on, and there's no what we call chevrons, right arrows at all. That's called a prompt. So although we saved our program, it isn't a program. This is part of just a screenshot of the shell, really. So it won't work, and the only way to make it work is to actually delete everything that is not part of the shell, not part of a program. Now we have something that would work, and the results are in the shell. Fred, Susan, Joe. It's looping around all the time. The only way to get out of it is by pressing Control Z or X or C. There we go. Finally, so that was Control C, which gave me what they called a keyboard interrupt. In other words, I've interrupted my program on the keyboard. I forget the rest of the error message. So that is sort of the shell is useful. We can use the shell. Let me just close that shell. Let me close that program. But it makes no sense to actually save a Python program in the shell. Makes no real sense to write the program in the shell, and we get a lot of problems. Now, everything that I've said you can happily ignore. If you just type your programs in an untitled document, that will be fine. Don't type your programs in the shell. That's all I'm saying. You will lead yourself into a lot of confusion, particularly if you didn't understand a word I've just said. But the shell is useful for trying things out. So if I want to try out a print statement, print hello plus Bob, it will happily do it. Okay, so it's a sort of test area, and it's also a calculator. So if I wanted to do some maths, I could do some maths. So if I wanted to do 2 plus 2, what do you think is going to happen? It prints 4. Now the maths operators, that's the plus. What I mean by operator is the plus or the times or the divide or subtract are like this. So that is plus 2 plus 2. If I do 2, take away 2, I get nothing. If I do 2 times 2, now that is not the times symbol, we'll give a mistake, typing mistake. The times symbol is the star, which is on shift and 8. So 2 times 2 is 4. And if you look on your keyboard, there is no divide symbol. So the computer uses the forward slash for a divide symbol. 2 divided by 2 is 1. So there are the 4 maths operators: plus, subtract, times and divide. We do need to know a little bit more about those symbols and what they do, but I shan't cover them too much at the moment. Let's take a look at something else. Let's do this. Let's do 2 plus 2, and I have put that inside inverted commas, so that is a string, and when I press enter, let's see what it prints. 2 plus 2. I could also write print and 2 plus 2, and that way it will not give me the single commas. Oops, it will do if I don't put the correct one on. So if I print 2 plus 2, it prints whatever's between the 2 speech marks. However, if I did this, print 2 plus 2 without the speech marks, it prints 4. So these are different. That in green is called a string, and that without the speech marks, using the same symbol, the plus symbol, is a number. So let's take this one step further. If I tried the rest of the operators, print 2 times 2 in inverted commas, what do you think will happen? It printed out the question. If I did print 2 times 2 without the inverted commas, what do you think will happen? It prints out the answer, not the question. So we can see there is a difference between a string and a number. And that is very, very important in programming. Now, I can, as you saw before, store a variable. So name equals Bob. And press enter. Looks like nothing's happened, but if I want to just type out print name, it prints Bob. I can store numbers in variables. So if I did this, num equals 3, Again, we've got nothing happening until I ask it to actually print out what the value of num is. And this time it is 3. Now remember, if we've got a cup that can hold things with a name on, and this cup is called num, we are putting the value 3 into the cup. We can also put into that cup the result of some maths, like 2 times 2 or 2 plus 2. So let's try that one again. Num equals 2 times 3. This time when I print out num, what do you think I'm going to get? 6. So it's worked it out and put the answer into num. Now I want to show you that these two are actually sort of different. Okay. So let's first of all try this. Print 2 as a string plus 2 as a number. That's a string because it's got inverted commas. That's a number because it doesn't have any. What do you think is going to happen? Let's press enter and find out. Okay, we get an error, which is what we expected, or at least what I expected. And if you remember, we read the errors from the bottom and work our way up. So let me try and explain what this error is saying to you, because this is really important. It says a type error. Now what we are doing is we are playing with things called data types. You may have heard those before, it's maybe new to you, but we can have different data types. Numbers are different to words. That's fairly obvious, and this is what this is saying. It's saying we cannot, now this is a computer word, concatenate, and what concatenate means, we cannot join. So concatenate is another word for join. We cannot, we've got a data type error, we cannot join str, which stands for string, okay, and that is our string there because it's between inverted commas, and int. Now int stands for integer, and that is a mathematical word which means straightforwardly just a whole number. Because we've got different kinds of numbers. We've got whole numbers like 1, 2, 3, 4. We've got decimal numbers like 2.1, 2.2, and that is actually a little bit different. So we can demonstrate that with the same sort of message. So if I do print 2 plus 2.3, we should get a different error message and different words here. So let's do that. Print 2, which is a string, plus 2.3, which is a number, but it's not an integer. It's not a whole number, it's a decimal number. Press enter. There we go. We've got a data type error. We cannot join a string and a float. Okay, I thought it was a decimal, they've called it a float. What it means is that this decimal point can float anywhere in the number. So I've got 2.3 there, it could have been 0.23, so the decimal point has floated from between the 2 and the 3 to go between the 0 and the 2, or it could even be something like 230.000, where the decimal point has floated from between the 2 and 3 to be between that. So that's why it's called a float. The decimal point floats in the number. Wow, that is quite a lot to take on board. So we've learned in this lesson that we can use the shell to do some work. It's quite useful to do some work. We can print things out. It will store the results of variables like num equals 3, and then we can use that later. I can use this sort of now, really. I can just type print num and it will have remembered what num was. There you go, it was 6. We've learned what a string is, anything between two quote marks, and it prints exactly what is between them. Okay, so in this case it looked like a sum, 2 times 2, but it didn't, it printed the actual sum. We learned that the times and the divide sign are different on a computer than you're used to when you're writing things down. The only one that we didn't really cover was the minus sign, or did we? Yes, we did. We did 2 minus 2 here. So plus and minus are the same, but times and divide is not the X, and it's not a divide symbol. We also saw that we cannot join a string and a number together. Okay, strings and numbers are completely different, and it's like putting a square peg into a round hole. It will never ever work. We also learned that the word concatenate means join. We saw what a type was, data type, is a different kind of information. We learnt what int was, which is an integer or a whole number, and we learnt what float was, which is where there's a decimal point and it floats in the number. So we've learnt quite a lot in this lesson. Now we need to put that to use and try to understand how we can use this information in our programs. So in the next lesson or next video, I'm going to explain a little bit more about numbers and what we can do, and in particular how to actually join them together, because that'd be quite useful.